Record, share my screen. All right, so today we are going to talk about Horos, and I'm going to demonstrate it for you. Before I actually get into demonstrating the program itself, I just want to talk about two other quick things. First of all, if anybody's interested in downloading Horos, I included the link in the syllabus, but I want to show you a little trick in case anybody's tried it. So here is the Horos page. It's horosproject.org. And if you click on the link to download Horos in the upper right, you come to this page that insists that you make a donation, which of course this is a new thing. It was always completely free in the past, and so you kind of see the writing on the wall that they may be trying to go to a paid model eventually. But turns out, if you look really closely, if you scroll all the way down, there's this inconspicuous little button that says, I choose not to contribute to Horos. So you can go there, and you still do have to sign up with them, but then you can go ahead and just download it and bypass the donation. So just in case anybody wants to install it, just keep in mind that I think I've mentioned a couple of times, this only runs on the Mac. This is not available for Windows. The other thing I want to do before I demonstrate the software is talk about where to actually access the data sets so that you can play around with the software and experiment with it. I think I mentioned to you, if you do work in the medical legal field, it's always very helpful to have the attorney send you the DICOM files on some kind of disk or post them to some kind of Dropbox or something so you can access them through the cloud. But if you're not actually actively doing that kind of medical legal work, you still need some way of getting hold of some of these files so that you can practice with it and learn. And so I've made a bunch of these things available to you so that you can learn the software here in class. So this is actually the web page for Osirix, which was the predecessor of Horos, and I talked a little bit about that history before. Osirix still exists, but you can only get the paid version, which some medical illustrators still do use the paid version of Osirix. If you go to the resources tab here on the Osirix page, and if you can't see the URL, it's osirix-viewer.com. If you go to resources, they have a link here for a DICOM image library. And they show you links to all of the data sets that they used to provide for free. And there's, I don't know, 52 of them or something like that. You can no longer access these for free. You have to purchase their premium membership, which is $8.95 a month, or at least that was the price last time I checked. I've always thought about, gee, maybe I should just join for a month, download the other 30 data sets that I don't have, and then cancel. But I have a feeling they probably make you pay for like a whole year in advance. So it's not just $8.95. But even so, it might be worth it to download the whole collection of data, because once you've downloaded it, you don't need the membership anymore. But the reason that I wanted to show you this link, and I think I've included it in today's assignment, I have downloaded 22 of these or something like that, and made them available for you on RIT's courses file share. The handy thing about going to this page is you just get an idea for what the different data sets are. So I think amnesics may be one of the ones that I've downloaded. So you get a little thumbnail image here. So at least we know that it's like abdomen, pelvis, upper thigh. There's a brief description. So it's a CTA. So it's a CT scan, but with angiography. So there's contrast fluid in the vessels of the abdomen and lower extremities. with iliac aneurysms. Okay, yeah, I think I've shown you this one with the iliac aneurysms. So you can just take a look at any of them, and you'll notice that they all have these dumb names that end in IX, Bofix, Brainx, Brevix, Carcinomix. I know Carcinomix is one that I've made available to you, and so on. So you just get a rough idea of what each data set is all about. Now, to actually access those, here in this lab, I've already pulled them up, but you'd have to go to the desktop, to the Finder window here. You go to the Go menu and choose Connect to Server. Now, normally when I teach this class, when I go to Connect to Server, it actually has like a whole bunch of the common RIT file share addresses already in there. I was a little surprised today that it did not have it in there. So I had to, thankfully I had it written down somewhere. I had to type in smb:// files with a hyphen .main.ad.rit.edu/courses. And when I did that, I clicked connect, and it placed this little hard drive icon on my desktop with the courses share. When you open that up, it looks like this. These represent the different semesters. So you can either click on 22-25, which is the current spring semester, or just click on current, and you'll see a list of all of the faculty who have set up shares for their courses. If you double click on me, if you're in the undergrad section, you'll probably only see 508. If you're in the grad section, you'll probably only see 608. But these are linked so that I think I only put the data sets in the grad folder, but I linked them so that if you go into the undergrad folder, you should still be able to get access to those. So in here, inside that folder should be a subfolder called Horos data sets. And if you expand that, you can see there's Assurance, Turix, and Brainx, and Brevix, and Calix, and a whole bunch of things ending in IX. I threw a couple other random things in here. Probably should get this person's name off of there because it's like somebody's actual radiology file with their name in it. A couple of those. There's a few in here, like I've got some of the data sets from the Visible Human that I'll share with you shortly. I've got a data set that you can download for free as part of Slicer. So in addition to 20 some odd data sets from OSIRIX, I've also got a handful of other random things in there that you can access. So that's where you'll access some of these files to work with Horos. If you try to do this from home, you'll need to either establish a VPN connection first. And I believe I put a link in the syllabus that where you can go and learn about RIT's VPN. RIT lets you download a Cisco VPN client, which is the software you have to run to establish a VPN connection. Or there's a new way to access the courses file share through the web. It's kind of slow. I find that the web one to be kind of slow, so I don't like it. So at home, if I need to access these data sets, or if I need to access the file share, I always establish a VPN connection and do it that way. Okay. So one of the things I'm going to have you do today, once I finish talking, is just have you poke around through here, open up the courses share, open some of these up. As I say, you may want to check the OSIRIX page just to get an idea of what each data set is, and then I'll have you explore some of those data sets in Horos. A couple other places to access medical imaging data. There's this new site that I had never heard of before. There used to be an older link to access CT data from the Visible Human project. I think I may have explained that briefly again, but just real quick. The Visible Human project was, gosh, I don't know, probably at least 20 years ago. They started out with a male who was a convicted murderer, I believe, who was set to be executed. And he agreed to have his body scanned by CT. And then he was frozen solid. And they ground his body away. They ground his frozen body down in thin little slices. So they would grind off a millimeter or two and photograph that cross section, grind off a few millimeters more, photograph that section. So when it was all done, this guy was just a pile of powder on the floor. And so they had captured images too. So there were both CT images as well as actual, photographic images of the different slices. For years, when I taught this course, the CT versions, oh, and by the way, then they did it with a female cadaver as well. For years, the CT data was available through a website at the University of Iowa. And I always, try to make sure I double check these things before I come into class. And sure enough, a couple of days ago, I was looking everything up just to make sure all the links work. And the data sets are no longer available through the University of Iowa. They said, oh, go check out this other page called XNAT. And the URL is simply central.xnat.org. It's like, okay, that's new. Turns out this is a new site. I believe it's a government-sponsored site that includes the visible human data, but also includes a bunch of other data as well from other imaging studies. So there's a couple of ways you can search this. Notice there's a series of tabs here. There's projects, subjects, MR, which is MRI, PET, which is positron emission tomography, which is not something that we've talked about in here before. And then they have CT. And to search by project or subject, you have to know the ID numbers for the different projects or the different subjects. And I have no idea how you even find that out. So what I did the other day when I first learned about this site is I just clicked on CT, for example, and didn't bother to enter any search criteria in here. I just left everything blank and hit submit. And it might take a few seconds. Actually, that was pretty quick. And turns out these are the only CT data sets they have. So by just leaving everything blank and not really entering any search criteria, I just got access to all of their CT data sets. And if you look over on the far right, where it says DCM, which stands for DICOM, patient name, anything labeled Eve is the visible female, and anything labeled Adam is the visible male. So if I wanted, for example, the head or the pelvis of the visible male, I would simply click, let's download his pelvis. They've separated Adam into, like head and neck, shoulder, thorax, pelvis and abdomen, and do they have, yeah, and then hip, which I think includes lower limb as well. But let me just download the pelvis one. When you click on it, it brings you to this page. Now there is something here, a box that says download, but it wants you to download an XML, which we don't want. What I found the other day is I actually have to click over here where it says experiment, click on this link that says CT session. And that gives us a different little box up here where I can say download, and I don't want the XML, I want to download the images. So it brings up this little dialog box. I can choose a compression format. I'm just going to leave it as a zip file. So it'll download a compressed zip file, click download. And it doesn't look like it did anything, but I'm pretty sure it is actually downloading that, I think. Yeah, actually it downloaded it already, so it's already done. So if I go and look in my downloads folder, so look up users, find my name, downloads. Sure enough, there's the zip file. Let me just drag that out onto my desktop. Double click the zip file. and it should expand it into a folder. I can get rid of the zip file now. So it'll expand it into this folder. If I look inside the folder, there's a series of nested subfolders, but then we have a whole bunch of DICOM image files from the CT scan of the visible human male pelvis. So you could go back in here and, all right, I think I have to go back. Got to go all the way back to the beginning, you know, search for CT data sets again. Now, if I wanted to get, you know, say his shoulder or his head, I could click on those links and go through that same process. So like I said, you can do that with the visible human male or the visible female. There are some others that are included in here, although now that I look at them, they all, when I look at the patient name, they all say 3-minute tutorial, 3-minute tutorial, name none. So it actually looks like the only real data they have here is the visible human data. But if I go back and maybe click on MR, these would be MRI data sets. You know, I could narrow it a little bit by choosing gender or maybe age of patient or something, but let me just try clicking submit with no criteria and see how many MRI data sets there are. And there's a whole bunch of these. And I could try to read more about them. You know, over here, there's a little descriptive paragraph, although a lot of it's in, you know, doctor gibberish, which, you know, if you don't know a lot about radiology, a lot of this might not even make any sense. But there are, here under type, there may be some information like, there's a whole bunch of them here that say glioma. So that would be a type of nerve tissue tumor, most likely a brain tumor coming from a glial cell. Thought I saw something that said knee, or am I imagining that? Did I see knee? All right, maybe not. A lot of gliomas and a lot of SNR20s, whatever that means. So I'm not going to bother downloading one of these, but you know, you could always spend some time exploring these. But at least, you know, you have access to a lot of MRI data here if you really wanted to retrieve some and explore it. All right, so that XNAT or XNAT, that's one source for data sets that are relatively easy to download. The last site that I wanted to share with you is called the Cancer Imaging Archive from the National Cancer Institute. And they have a huge collection of CT and MRI data, as well as other kinds of imaging. I think there's some ultrasound, there's some PET scans and things like that, but we're mostly interested in CT and MRI. So when you go to cancerimagingarchive.net, there's a link here to access the data. You can browse their data collections. And you'll see that brings up a very long list. And if I remember correctly, this goes on for multiple pages. No, not too much. We're looking at 125 out of 181 entries. So there must be a second page. But if I scroll back up to the top of the list, you can click any of these headings on these columns and sort the data by cancer type. So for example, if I click on cancer type, it's going to sort that column alphabetically. So we could look at imaging studies of acute myeloid leukemia, adenocarcinoma of the lung, adenocarcinoma of the colon, adenocarcinoma of the pancreas, and so on. Pay attention to species. So location, you know, tells you obviously what part of the body. Pay attention to species. I don't really want to look at adenocarcinoma of the colon of a mouse, although I don't know, maybe that would be kind of fun to look at a CT or an MRI of a mouse. But also next to that, you have data types. And so these acute myeloid leukemia, it just says pathology type. So those may literally just be photos of leukemia cells. But here's one that says CT, MRI, PET scan. What's CR? Not sure what CR is. Pathology images. Here's one, MRI, CT, MRI, PET scan, etc. So you want to pay attention to the type of imaging study too. So what would be an interesting one to do here? This might be an interesting one. We got a colon cancer, human. I think this number tells us how many images are in the data set. Well, I don't know, subject, that may not actually be number of images, but I'm going to go ahead and grab that one. Oh, I mentioned before how every time I do this, something changes. Like I found out that University of Iowa no longer has the visible human data set. Things change literally every year. One thing I'll warn you about right now with this cancer imaging archive, in order to download the actual data, you actually need to install a little app. There's an NBIA installer app that has to be installed on your computer. And I've done that at home, so I can retrieve these things all day long at home. And you could do that on your own personal computer. But I have a feeling when we get to that step here, because of RIT's security, it may not let us install the app that we need to download it. So I'm showing you this in case you want to do this at home, but just beware, there's a really good chance that we won't actually be able to retrieve any of this here. Yeah. I believe it's called the NBIA downloader app. It'll actually tell you that when we get to that stage. And it'll provide a link to download that if you want to put that on your own computer. So I'm going to click on this CT colonography link, at the far left here. And when I get to this second page, I want you to be really careful about something. There's a bunch of big blue buttons that say download. Don't click those unless you want to be here for a couple of hours, because that is going to download the entire data set, which in this case is 462 gigabytes. This data set actually probably includes CT images from multiple different patients. So if you download it, you're going to get CT data sets from a whole bunch of patients. We can actually filter that by clicking the orange search button instead. And it brings up this annoying screen here. We can just click close that. And here we actually have the patients that were included in that large CT data set. And turns out, yeah, there are actually 825 different individuals, 825 different imaging studies on different patients that are included. So if I had downloaded the whole collection, like I said, I would have had, almost half a terabyte of data, which you definitely don't want to do that. The one downside to this is that all I get here is, I know it's a CT colonography, and then I get this subject ID number and not a whole lot else. It does tell us that some of these, they only did one imaging study. Some of them, they did two different kinds of imaging studies. But I don't really know what's in here until I download it. And I've always gotten a kick out of this. The way you actually download these, it's like shopping for CT scans on Amazon. You have to click the shopping cart icon and put them in your shopping cart. So I'm going to click here and put that one in my shopping cart. And I don't know, maybe I'll do the one with 2 studies and put that in my shopping cart. Yeah, I'll just randomly pick 3 of these. I mean, there's more than 6 pages of results here, so I could pick dozens of these if I wanted to. But now that I've clicked these and put them in my shopping cart, just like Amazon, there's a little shopping cart icon here in the upper right. Click on that, and all right, some of these, now I get actually a little bit more detail. I'm realizing now that some of these data sets only include 1 image. So I'm going to deselect anything with only 1 image. I want the ones with hundreds of images because those are the ones we can reconstruct in 3D. So now I've kind of updated my shopping cart. Now we get to find out if this is really going to work or not. Now I can click the download button. And it's downloading something called a manifest, which is really just a list. If I double click on that manifest file, then it's going to say, okay, there's no application to actually download this stuff. Let's see, there's another way though where it tells us which app. Maybe if I click the download button up here, instead of the green download button, there's this other download tab. There we go. Get the NBIA data retriever. That's the name of the app. So tells you where to get it for different operating systems. You can retrieve the NBIA data retriever in the Mac App Store. Okay, that's annoying. All right, so I can try getting this, and this is where we'll find out if it's going to let us install this thing or not. Oh, really? Okay. It wants an Apple ID. All right, well, I do have an Apple ID. I don't think I've run into that before. Really? And you're going to show my Apple ID to everybody? Don't look. Really?
Turn off the share screen.
Okay, that would be. But that, yeah, everybody will still see it up there. What? Oh, that's poop. That's my password. Oh, really? Is this my? I don't even know what my ID is. That's my RIT name. Now I can put in my password that everybody saw. Oh, and it just sent me a verification code to my phone. What a pain in the ass. Okay, so after all of that, whatever. Let's see if it's actually going to install it or not. Says it did. Okay. So it claims to have installed it. So now if I go back to my, it downloaded something called a manifest file, which I saw earlier. I'm going to go back into my downloads folder. Okay. So it's, all right, so it actually did let me install it, and it has retrieved the NBIA data retriever app. And now it's not letting me download yet, because what I have to do is click the browse button and just choose a folder, tell it where to put the file. So I'm going to go back to my username and put it in the downloads folder. Okay, now that I've chosen a destination folder, I can click the start button. So I don't know, if you're going to remember this, but I guess, at least we are recording. So, oh, and now my Apple ID is recorded. Okay, that's why somebody said pause the recording or the screen share. All right.
You can always go in and
Mhm.
out.
Yeah, really.
Those black box. Kind of getting past it.
Mhm. So you can see the status bar for downloading all these data sets. I probably should have chosen fewer because it's taken a while, but it's not too bad.
I just come see. Go down.
Yeah, if I start seeing iTunes purchases popping up in my account, I can narrow it down to 25 suspects. Almost there. Okay, so it is done downloading those data sets. They are now sitting here in this folder in my downloads folder. So I've got this one that we downloaded from Visible Human. We've got all these Horos data sets or Osiris data sets that I had downloaded previously. So we got a whole bunch of data that we can start playing with. All right, so I'm going to go ahead and get out of there. Just hide that. All right, let me start demonstrating Horos for you. So in the applications folder on all your computers should be a folder called Perkins SciViz, because I'm about the only person who uses any of this stuff. So every spring I have to have them, reinstall all this stuff for me, and they just stick it all in this little folder for me. So I'm going to go and open up Horos. And they ask if we want to share our information, maybe later. And what we start out with when we first open Horos is what's called the database window, which is just where we can see all of the sets of data that we have installed into the application. So there are three really simple ways of getting your data into the into Horos. There's a button called import. You just click the import button. I think also under the file menu, there's an import command, import files. Or the simplest thing is just to drag a folder from your desktop and just drag it right into the window. And it asks, do I want to copy the files or just copy links to the files? I usually copy files. It makes a duplicate that it stores in the Horos folder, although it doesn't really matter on these computers since these computers get wiped out and reset every night anyway. But on my home computer, I say copy files. So I've just installed the visible human male pelvis data set. You can see it shows up under the patient name Adam. I'm going to bring in the 3 data sets, or maybe, I don't know if I'll bring it all in, but bring in at least one of these CT colonography data sets from the Cancer Imaging Archive. So, just grab one at random, just drag and drop the folder, copy files. And then grab 1 or 2 from the course's file share. Let's try carcinomics. It's probably more important to copy files when I'm dragging them off the server because, once I close the server, those files won't be available. But as long as I copy them, then they'll always be available here in Horos. I'm going to grab one called Mannix. Copy files. That's a little bit bigger data set, so it's taking a little longer. Okay, so everything's copied in. So let's just explore this database window a little bit and see what kind of information we have here. So first we've got the patient name. And if you look under these patient names, you'll see all of them have a little triangle next to them, which means if I click that triangle and expand, we'll see that there are actually multiple different imaging studies that were performed on that individual patient. So in this case, it looks like there was a CT of the colon that was performed with the patient in the supine position and one in the prone position. I didn't realize that really mattered very much. But, so you can tell there are 2 different studies that have that difference. Adam, visible human, there's only 1 from his CT of his pelvis. Carcinomics only has 1. Mannix has a few. The people who first created Osiris, if I remember correctly, they were from Switzerland and they speak French. And so a lot of the information that's included with the Osiris data sets is in French. So it helps to know a little French. Like there's at least one data set where I think it's the Phoenix data set where one of the studies is identified as OS, which is French for bone. And here under Mannix, there's one called avec IV and one called sans IV, which means with or without IV contrast fluid, intravenous contrast fluid. So, like I say, helps to know a teeny bit of French. So, what other information do we get here if we scroll over? Let me grab. Let me look at the avec IV here with the IV contrast. So there's a description of the study, and you can enlarge these fields if you can't read everything in there. Crane with cranium, head. I mean, it actually says head, axial. One of these other ones up here, thoracoabdominal, CT thoracoabdominal, et cetera. So you can get a little bit of information about what the study was that they performed. Let me go back here. There's imaging modality, what kind of imaging it was, and it just so happened that all of the ones that I downloaded were CTs. Some comments, again, talking about supine, prone, with or without IV contrast, the date of the study, probably one of the most important fields, whoops, didn't mean to do that. One of the most important fields is this number of images. That tells you how many separate slices are in that particular study. So going back down here to our Mannix data sets, I noticed that one study only has 48 images, another one has 48, one only has one image, but there's one here that has 460 images. So if I want to reconstruct a 3D model, I always want to pick the one with the most images, because I'm going to get the best resolution. Some of these, here's one with 436. The visible human male is only 140, so that's kind of low res. There's one with 652. So I'll always look at that number of images and try to pick one with a lot of images. So I'm gonna go ahead and pick this angio CT. So probably CT angiography. So there is contrast fluid in the vessels, and it's got a lot of images, 460, which is a good number. So the next thing I can do is up at the top of the Horos window is a little button that says 2D viewer. If I click the 2D viewer, what that does is it allows me to view the individual cross-sectional slices that are included in this data set. So here's one slice, and I can just use the left and right arrows on the keyboard. And I'm using the right arrow right now to just scroll through and explore the different slices. So I actually, I'm going to go back to the beginning here. Started down inside the thorax. There's the aortic arch, that big white sausage in the middle. And then as I scroll up, I'm actually going up, farther up into the thorax. We're seeing that the lungs are getting smaller as we get up towards the apex of the lung. Now we're getting up. That's probably like the T1 vertebra right there, the first vertebra with a rib. Now looks like we're getting into a cervical vertebra. And you can see the trachea, that big black oval is the trachea. Remember, the trachea is always held open by cartilage, and it's going to be filled with air, so it's going to appear black. Starting to see his chin coming into view up here at the top, and that white is going to be his mandible. And now we're kind of like in the tongue. Now up into his upper jaw, you got some upper teeth there in the maxilla. Those may be dentures, because I don't think they actually show up very well in the CT. Up into the nasal cavity. These big black spaces on either side of the nasal cavity, those are the maxillary sinuses. So you can just, explore the anatomy and cross section. Obviously eyeballs and ethmoid air cells here between the orbits. And now we get up into the brain. So anyway, if you had reason to look at individual cross-sectional images, you could do that here in the 2D window. But the real fun with Horos and the stuff that I find most valuable is the 3D reconstruction. So I'm going to show you two different kinds of 3D reconstruction. I'm going to start out by showing you a 3D surface model. And if you remember from the other day, when I was describing a 3D surface model, that's where OSIRIX looks for a really sharp boundary between light and dark pixels. and builds a surface, a three-dimensional surface at that interface or that boundary. So there are a couple ways that I can go from this 2D window to a 3D surface model. There's a 3D viewer menu up at the top, and I can select 3D surface rendering. Or alternatively, there's a button up at the top of the window called the 2D 3D button. I click on that, and I can also choose 3D surface rendering. Either way, they do the same thing. So I'm going to choose 3D surface rendering. And it's going to ask me for some information here. Resolution, I'm going to choose the highest resolution, so I'm going to set that all the way up to high. Now I want something called a pixel value. The pixel value is basically telling Horos which interface to look for. Do we look for the interface between skin and air? Do we look for the interface between bone and soft tissue? Because there are these different interfaces. And honestly, I don't know very much about what the numbers mean. Thankfully, Horos has a bunch of presets built in. So if I say choose the correct number, which happens to be -500, to find the boundary between skin and air, I can choose that. I could choose to make that surface transparent once I've created it. I'm going to leave it opaque. I'm going to leave this. This actually means it's going to be solid. If I slid that over, it would make it transparent. And I can apply a color to that surface once it's built by just clicking on the little color swatch. Going to my color picker here, and I could pick a nice brown color, something like that for skin. And then click OK. It might take a minute. And there he is. So once I've reconstructed him as a surface model, I can move him around and explore. I can rotate. I can move up or down, left and right. I can zoom in and out. I've got some simple navigation tools up here. I've got a magnifying glass, which drag one way to zoom in, drag the other way to zoom out. I've got a rotate tool here that rotates only around one axis. I've got a translate or move tool, which just lets me move left, right, up, or down. And then probably the most useful tool is this little 3D cube that lets me rotate in any plane. So I can rotate him around. The cool thing about this is not only does it find the interface between the skin of his face and chest and the air around it, but if we rotate it up, we can see it's also found the interface between air and the inside of the respiratory tract. So we can then zoom way in on that. And you can actually see, if you look way up in there, we've got things like the maxillary sinuses. We've got different parts of the nasal cavity. We've got the larynx, the pharynx and the larynx. Here's obviously the trachea. You can tell from the ridges on the trachea. And then you can see some of the bronchi extending into the lungs. Actually, if I zoom way in there, we can actually go right up inside his head and explore some of the things in here. So up here, this large smooth thing, that's the inside of the maxillary sinus that's embedded within the maxilla. And you've got the nasal cavities in between the two maxillary sinuses. Then we've got pharynx back here, nasopharynx behind the nasal cavities, oral pharynx behind the oral cavity. And I thought this was kind of cool. I wanted to zoom in on this because this is actually showing the space inside the middle ear. So actually that's probably external acoustic meatus laterally. And then somewhere in there would be the tympanic membrane. And then this is all like middle ear cavity, where the bones and things are, the ear ossicles. All these little blobs down here, these are actually what are known as the mastoid air cells. The mastoid is filled with little air sinuses. So you can see all of this stuff. And to get back out of the head, we just use our zoom tool and back up. And back out. And we can rotate him back into position. But that's about all we can do with one of these 3D surface models. You really just zoom in, zoom out, and rotate and move around. We do have the option of adding a second surface. So you're not limited to just looking at one surface at a time. You can view the skin and view the bones simultaneously if you want to. Actually, let me just view bones first. So I'm sorry, I did something quickly without telling you. When you're in this 3D surface view, there's a little picture of a face here that says surface settings. So if you click on that, it brings you back to these settings. I could change my one surface to bone, and notice it enters a different number there. And I could change the color, maybe go a little bit more yellow for bone. Why it's not updating. Okay, there it is. And then click OK. So I'm just viewing a different surface now. I'm going to view the bone surface. All right, so there's the bones. And it's pretty good. There are definitely some defects. Like a lot of his maxilla is missing. The vertebrae look very, very fragmented. You can try to make this better by going back into the surface settings and changing this number, this pixel value number. But I have to admit, since I don't really know what that number is telling me, it's completely trial and error. And I've always had a very difficult time trying to get good bone surfaces. No matter how much I tweak that number, it doesn't seem to make a huge difference. So if I change this from, say, 500 to 300 and click OK, it does something, but let's wait and see what it looks like when it's done spinning. Yeah, did it change anything at all? Maybe a little. So, I have mixed success with the bone surface. But all right, let me show you one last thing with the surface models. If you go back into your surface settings, I started to say this before, you can add a second surface. So we'll leave the first surface as bone. Second surface, we'll make that skin. I guess we'll give him pink skin this time. And click OK. So it's just, but something I need to do. If I want to be able to see the bones under the skin, I need to change the transparency of the skin layer. So I'm going to push that little slider down to make the skin partially transparent so you can actually see the bones inside.
When I try to pull up the research, it's all like grayed out. It doesn't have like you know, whatever.
Really?
I'm looking for it also.
Really?
Where do you go?
Yeah, so did you go to 2D viewer first?
Yeah.
So when you select the data set, click the 2D viewer button first. Then once you're in the 2D viewer, then try going to 3D surface. Okay.
Yeah. I love them there.
All right, so if you look up on screen, you can see what we have now is we've got this partially transparent skin, still including, you know, the trachea and bronchi, but now with the bones inside. I'm going to go back into my surface settings one more time. I'm going to just view the skin again. Okay, so I've gone back to just having one surface of his skin. Last thing I want to show you with surface models is these are the only models that you can export in 3D, in a 3D format. Let me just wait a second. Are we still having people having issues with being able to follow along? Anybody else struggling? Don't like take the head and it's based here. And it may be only the 3D model here, 3D here. So if we and they should go to I had to fix this on their file. If they have this in Econ, or even if they have a font, it's trying to split the screen. So like they try to do it to be window here and it's. You gotta go into system preferences and tell it to keep the mirror. Okay, real quick, I'm just going to show you one last thing with the surface model. Then I'm going to take a longer break, let you guys take a longer break and run around and troubleshoot any more issues. And then we'll come back after the break and I'll show you what to do with volume models, which are actually, I think, a lot more fun. But all I want to show you is that the surface models are the only things you can export in 3D. There should be a button here in the upper right corner where you can export. You can export as a wavefront OBJ file, which would be wonderful for bringing into Maya. You can try exporting as a VRML, which will open in many 3D programs, or STL, the stereolithography format for 3D printing. I've had probably better luck with STL than VRML. So if I export that 3D file, let me put it on the desktop. Might take a minute because it's a fair, well, that wasn't bad. It's going to temporarily hide Horos. So it should have put, there's something just called 3dfile.stl, which I could bring into a 3D program. But I went ahead and preloaded something to show you. So here's Maxon Cinema 4D, which is really the only 3D program that I dabble in a little bit. And this is an export that I did from this dog thorax. I showed you a screenshot of this before, but you can see that it really is, you know, a 3D model that came from exporting this as a surface model. One thing you might notice, if you look closely, especially at the ribs, you see a lot of jaggediness. That's unfortunately an artifact of the fact that this data is coming from a series of slices. And Horos is simply trying to connect the slices together. But you often get that kind of stair-stepping appearance because of the stacking of the slices. And that's pretty much unavoidable. So that's why a lot of people end up, just re-topologizing or, reconstructing these things in Maya or in Cinema 4D. All right, so that's all I wanted to show you with that. So go ahead and take a little bit longer break if you want. I'll run around, do any more troubleshooting. Then I'll come back and show you some things about volume models. Yep. Yeah. Yeah. But did you already get something? Yeah, they we actually have to do and be data retriever app or something like that. If you download, you see this thing called a manifest file. And then it wants the manifest file that's looking for this downloader app. So if you click on this download tab here and say get the retriever, then you can so this is where it wants your application. You don't make the mistake I did and put your password in your user. But the surprise is this update that suggests that it thinks it's already here. Huh. Let's see if the older version works. So apparently it's not. Yes, you. I mean, it's not critical that you download data from the cancer imaging archive for today. I wanted to show people that in case want to be able to home and on your own computer, download data, and you have to make sure you download that in the downloader now. So, I mean, if you want to just skip that part, don't worry about it. There. So I don't worry about it.
Yeah. Valley. The bottom of it. Yes. Yeah. Okay. Yeah.
Downloading the data. Everybody.
Yes.
Scanning. No, nobody.
Oh.
I'm gonna move forward and demonstrate something you can do with volume models. Like I said before, I think there's more you can do with them to play with. I just want to call your attention, if you hadn't noticed, in my courses, I posted a copy of your first assignment, which is really just a class exercise. And one of them is simply to export a JPEG of a rendering of the surface. I think I put some criteria in there, like I think I wanted 2 models, like bone and skin or something more transparent. So there's some parameters, but all I want for that is just make sure that you actually come through and play with the surface model. And then the second part of the assignment is to do something very similar with a volume model. Demonstrate that. So there's 2 separate Dropboxes up on my courses, one for you to upload your surface model rendering and one for your volume model rendering once we get to that point. Right, so I'm just going to close the 3D surface model window. Just click the little red button, close that. I'm going to click the red button, close the 2D view, and that's going to bring us back to our database window where we can see all of our different data sets. And for this next part, I'm going to try a different data set. Let's try this carcinomics. And starts out the same. We just select that data set in the list, click the 2D viewer. And if you want, you can scroll through here. So these are the shoulders and the neck. You can see the humerus and some of the cervical vertebrae. Now we're going to work our way down into the lungs, down through the thorax. There's the aortic arch again. So just, quiz yourself on cross-sectional anatomy. And now to generate a 3D volume model, same thing. You can either go to the 3D viewer menu or just click the 2D, 3D button with the little gear icon. And this time choose 3D volume rendering. Okay. I think that's okay. To reconstruct something in a 3D volume, Horos needs to know the spacing of the slices. So that was some little warning about the spacing of the slices, but it seems to have worked just fine. So here's our 3D volume model. And I have many of the same tools that I had before with the surface model. I've got a move tool where I can just move around. I've got a magnifying glass tool where I can zoom in and zoom out. I got this rotate tool that rotates in one axis. And then probably the more useful one is the tool that lets you rotate around in 3 dimensions. And just so happens that when this volume model comes in, the skin is hidden. And you can actually see the musculature pretty clearly, like especially down in the thigh. Down here, you can really clearly see thigh muscles like tensor fasciae latae to the outside, and sartorius and rectus femoris in the midline. Here in the abdomen, and we've got these very large rectus abdominis muscles with little tendinous insertions, and there's an external oblique. And up here you can see pectoralis major muscles, and there's latissimus dorsi in the back. His arms are fully abducted in this particular view. So that kind of alters the anatomy a little bit. But in addition to just these basic moving tools, one of the really, really powerful tools, really important tools for working with these volume models is something called the window level tool, which is something that looks like a little gray gradient, a little black and white gradient here in the upper left corner. This is the thing that allows you to adjust the transparency of different parts of the image, different tissues. So I'm going to select that window level tool. And the way this works is that you can drag with the tool left or right or up and down, and it will alter the transparency of different tissues. Now, a word of warning about this: make small movements. Don't drag the thing way off the edge of the screen, because it'll make such a big change in the transparency that the image is likely to either completely disappear or just turn into a bunch of static that's unrecognizable. So you want to generally make pretty small movements and gradually change the transparency. So I'm dragging to the right now, very gradually, and it's actually putting the subcutaneous tissue and skin back on. So I'm actually, turning back on tissues that had been made transparent previously. And so then if I do the opposite, drag to the left, or drag up a little bit, it's gradually changing colors and changing the transparency of tissues. And if I continue doing this, eventually it's going to hide all of the soft tissue, and we'll be able to see mostly just bone, although notice that the colon is pretty visible in here. So I think they must have had some contrast in the colon. As I rotate this around, you can clearly see the different parts of the pelvis down here, the ilium and ischium and pubic bone and the sacrum in the back and femurs. You can really clearly see the iliac arteries. Yes, here's the external iliac crossing the pubic bone to become the femoral artery. In fact, you can even see the profunda femoris, or deep femoral artery, branching off of the femoral down in the thigh. As I said, there must be some contrast fluid or something in the colon, because it's showing up pretty distinctly. Higher up, of course, we've got ribs and sternum, and inside the thorax, you can make out the heart pretty clearly. Some of the pulmonary vessels, you can see the aorta in there. The aorta is partly hidden, but I mean, you can certainly see the aortic arch way up high in the thorax, and then arching down to become descending aorta or thoracic aorta. You see you can really tell the abduction of the upper limb here. You can see how the the humerus is really fully abducted at the glenohumeral joint. But you can also tell the clavicle is tilted up a little bit, which is always going to happen when you abduct. So there's a lot of, a lot of interesting anatomical things you can see in here. But when you open a data set and you start playing around with this, just play around with that window level tool. And dragging vertically up and down and dragging horizontally left and right are doing two slightly different things. And it's almost impossible for me to explain it to you now, but in a few minutes, I'm going to show you something else that'll make that difference a little bit more obvious. It's like, why is it that, moving up or down or left or right is changing not only the transparency of tissue, but also the color of tissue. And I'll try to, make that clear for you what's going on when you do that. All right. So that's the window level tool. There's a set of pop-up menus here. There's something called WLWW, something called CLUT, opacity. Don't worry about opacity, but these first two. So that little grayscale tool that I was just using to change the transparency is called the window level tool, and it's window level is really referring to the, like I said, the opacity or transparency of different tissues. This and window width, again, I'll explain what those two terms mean in a minute when we can actually see it visually. But there are presets for these things. So there are presets for window level and window width. So we can do CT of the abdomen. We can do CT of bone. And okay, that doesn't look much like bone, so I'm not sure what that's supposed to be showing us. CT of pulmonary. Yeah, all right, that doesn't look too good either. This is what happens sometimes if you drag the window level tool too much, is you just get this block where everything's all static. If you find that you drag the window level too far and you just get a massive static or everything just completely disappears, one useful thing is under this WLWW menu, if you go to default window level and window width, that brings you back here. So that will restore your image if it ends up vanishing because you move the window level tool too far. So I don't use this menu very often. The main time I use it is if I just need to come back to this default setting. The thing that says CLUT, that stands for color lookup table. The other day I was describing how Horos analyzes the different pixels or the different voxels in the image, and recognizes there are light pixels and intermediate gray pixels and dark pixels, and it assigns colors to each of those pixel values. And it does that by using what's called a color lookup table that basically just says, okay, for this value of gray, replace it with this color. For this value of gray, replace it with that color. There are default color lookup tables built in here as well. I think the normal default one is this thing called VR muscle and bone, but there's a whole bunch of other things here. There's black and white inverse that makes it look kind of like an X-ray image. There's some really weird ones like GE color, puts in these strange colors, or GE rainbow. It's gonna be gray rainbow. Hot metal, whatever that's supposed to mean. I don't know who programmed these things in here. I don't know exactly what the purpose of a lot of these things are, other than just, ooh, look at the pretty colors. That's different. I don't know why this one named after UCLA. But anyway, you can play around with those, but I tend to just stick with your basic VR muscle and bone, the default one, because that seems to do a pretty good job of applying, yellow and white to bones and applying red to muscles and internal organs. Let's see. There are also a bunch of what are called 3D presets. And if you click on the 3D preset button, all right, take a minute, I guess. What you get are a bunch of settings that the makers of Horos have created that are going to change things like the transparency of tissues, the colors of tissues. If this thing ever opens, you'll see what I'm talking about. I don't know why it's taken so long to open that. Makes me worry that we're going to crash. That's not a good sign. All right, maybe we'll skip the 3D presets, but I may have to force Horos to quit if this doesn't come back to life pretty soon. Yeah, that's not a good sign either. All right, sorry about that. I'm gonna have to quit Horos. And we'll come back to it and I'll resume the demo and I'll just skip the 3D presets so we don't run into that again. Hopefully, at least it kept the data stored in here. All right, that's good. Kept the data. All right, I'm gonna stick with carcinomics, 2D viewer, 3D volume rendering. All right. So I'm going to skip the 3D presets since it didn't seem to like that. It's not a big deal. I mean, I don't use those very often anyway. It's just another way of changing the opacity and colors of tissues. I'm gonna come back to this color lookup table editor in a minute. I'm gonna jump ahead to the crop tool because the crop tool is really a really useful feature. Crop tool is this little thing, looks like a cube with a bunch of little green balls on the surface. When I choose the crop tool, it actually turns on this box around the patient, and there's a series of green dots on the box. There's one on the left side, one on the right, one on the front, one on the top, one on the bottom. There's also one in the back, which is hidden from view. But these will let you crop in any plane. So if I drag that top box, I can drag down and crop in the axial plane. If I grab the one on the left and drag it over, I can crop in the sagittal plane. I want to rotate my view, but here's a word of caution. Before you go back to this 3D rotate cube, make sure you turn the crop tool off by simply clicking on the little crop tool icon again, and then the crop tool goes away. What I find, if you leave the crop tool on and then try to rotate your image, sometimes what it does is it takes the cropping cube and actually rotates the cropping cube relative to the body. So you want to turn off the crop tool, then rotate. And, I think this is pretty cool how you can now, by cropping away the rib cage on the left, now you can look in and actually see that the heart is partially cut also. And then you can clearly see, pulmonary trunk coming back from the right ventricle, aorta coming up and into the aortic arch. And you can see, some of the major vessels coming off the aorta, and then see the descending aorta dropping down, and, see things like liver and different parts of colon and so forth in here. So we can rotate that around. If I go back to the crop tool, I can undo the cropping in the sagittal plane just by pulling the little green dot back out. And I can grab the dot in the front and crop in the coronal plane. Crop off the front of the abdomen, front of the rib cage. Remember, always turn the crop tool off before moving. So then we can move around. Zoom in, see the heart, starting to get cut in coronal section. Again, aortic arch, liver down here, probably stomach. That's you can actually see some of the branching of superior mesenteric artery in the mesentery of the intestines. All right, so now that I've quickly shown you the crop tool, now let me show you this color lookup table editor, because I think this is a good view to demonstrate what the color lookup table editor does. So I don't normally click the 8-bit one. I click the 16-bit color lookup table editor. And you'll notice right away it dramatically changes the transparency of different tissues in the image. The important thing to look at is down at the bottom of the image. I'm going to try to drag this up so it's a little bit more visible for everybody, and expand the size of the graphs down here at the bottom. I explained this Monday in my lecture. Let me go back over this. There are two different graphs that are visible here. In the background, there's a gray graph or gray histogram. And remember that that gray graph represents the range of gray values that were present in the pixels of the original imaging study, where the darkest pixels are represented by the left-hand end of the graph. The brightest pixels, the white pixels, are represented by the far right-hand end of the graph. And then the pixels of intermediate gray value are here in the middle of the graph. And the height of that gray graph in the background tells us how many pixels there are in each gray value. So this big spike at the far left represents, it just tells us there's a lot of pixels that are essentially solid black. And mostly that's referring to all the black pixels out here, in just the air. And then there are somewhat fewer pixels in these darker grays, the 80%, 70%, 60% gray. Then we get in the middle of the value range, around 50% gray, and we get a couple more peaks. That would correspond to tissues of intermediate density, like muscles and some of the internal organs. And then at the far right-hand end would be our lightest value pixels, which would be our bones and any metal or anything that might be present in the body. Okay, so that never changes. That just represents the values that were present in the original imaging study. The colored graph is the thing that changes, and that's the thing that I'm going to edit as part of my color lookup table editing. Notice that the colored graph is really small, and it only covers a narrow range of the gray areas in the other image. Okay, and notice that my image is now spinning around. I don't know if anybody else has run into this yet. I forgot to warn you about this. There's this really dumb default setting in Horos that after, 3 minutes of being inactive, it starts spinning the model around just for the hell of it. So I need to go to the Horos menu, Preferences, the little 3D icon that looks like the little 3D head here. And down here under miscellaneous, auto rotate objects after 3 minutes in volume rendering. So turn that off, close it. Now I have to grab hold of it and say, okay, stop moving. And now that won't come back on anymore. I've always thought that was kind of silly and kind of annoying. Anyway, okay. Back to the little graphs down here, the color lookup table editor. So notice that the colored graph is very narrow and it's only covering a small portion of the range of gray values that are present. That's why so much of the image up here is transparent, because only the areas that fall under this this colored graph are actually visible. Now let me go back to my window level tool, that little grayscale tool up here. This is the thing that changes the color and transparency. And what I'm going to do is I'm going to drag up and down, and I'm going to drag left and right. And keep your eye on that colored graph as I do that. And now you'll be able to see visually what's actually happening when I use the window level tool in Horos. So first I'm going to drag left and right using the window level tool. I'm going to do this on the image itself. If I drag left, notice it's squeezing that colored graph and making it even narrower. So now there's a really, really narrow range of the image that's visible. If I drag to the right, it's going to do the opposite. Drag to the right, it's stretching that colored graph farther out so that it encompasses a larger range of the grayscale values that are present in the imaging study, which has the effect of making more of the tissues visible. So that's what's meant by window width, is how wide that colored graph is relative to the grayscale values of the original image. So by dragging left and right, we determine how much of the image is actually visible. Now watch what happens when I drag up or down. If I drag up, it slides the whole colored graph to the right. Now, once again, very little of that colored graph is actually overlapping the gray values, so very, very little of the image is actually visible. If I drag to the left, whoops, sorry, that's not what I meant to do. If I drag down, it drags the colored graph farther to the left. So now, a different group of pixels are visible. If I drag this farther to the left, interestingly, all the bones will disappear because the far right-hand end of the graph is not covered by the colored area, but all of the soft tissues are. So I can slide this thing up and down, left and right, and change, the appearance of the image. Now, going back to the colored graph down here, the color lookup table editor, the other thing that I can do here is I can change the colors of the individual dots in here, and I can also add more dots or subtract dots. So notice that there's a red colored dot that lies right kind of in the middle of the grayscale range. Then there's a yellow and a white dot over the far right. If I just click on that red dot or double click on it, it brings up our little color picker again, and I could change that color to green and make all my muscles and all my soft tissues green. I could click here on the yellow dot and, change that to purple or something, make all the bones purple. So I can do stuff like that. I'm going to actually set these back, set the bone color back to yellow, set the muscle color back to red. But now I'm going to add a new dot. There's actually a black dot way over here at the far left. I'm going to drag that farther to the left. I'm going to add a new dot right here that lies kind of right around, I don't know, 60 or 70% gray. Drag that up, and I'm going to color that blue, and I'm going to increase the brightness of it, make it a brighter blue. So where I place this blue dot corresponds roughly with the gray value of the inside of the lungs. Because remember, the lungs are very low density, so they're dark gray, although they're not completely black. So I've been able to apply a blue color. I'm going to change the blue a little bit. I'm going to apply a blue color to the lungs. And I don't know if you remember this from Monday, but the final thing that I can control here in my color lookup table editor is the height of the dot determines how opaque or how transparent those pixels are. So if I drag that blue dot way up to the top, anything that coincides with that color blue becomes completely opaque and solid. Whereas if I drag it way down, anything that's colored blue becomes more transparent. And this is very similar to the example I showed you in the PowerPoint lecture the other day, where I had a blue peak coinciding with the lungs, a red dot for soft tissue, like the muscle and the internal organs, and yellow and white for bones. So I can then rotate that around up here and see what that looks like. Or I could change my cropping. I could undo the cropping in the coronal plane and instead crop into the sagittal plane from the left. And then rotate that around and see what that looks like. So I want you to play around with these different settings. I want you to play around with cropping. I want you to play around with different colors. You can use the color lookup table presets from this CLUT menu, or you can actually click on the button to go into the 16-bit color lookup table editor and really play around with this in detail. And once you really become comfortable with this color lookup table editor, it can be really, really helpful in helping you visualize certain tissues in a study while hiding other tissues. Once you're done with the color lookup table editor, there's a little X here next to the graph, so you can simply close that. And then your image gets a lot bigger. One more thing I want to point out to you. With a lot of these imaging studies, there are objects that show up in the imaging study that sometimes get in your way, and you might want to remove them. Actually, I'm going to go back to the Mannix data set because that's a really good illustration of this. I go back to Mannix and 2D and then 3D volume rendering. So here's Mannix. And if I use my window level tool and put all of his skin back on, notice he's got these two pads next to his head that are holding his head stationary. There is a way to remove objects like that from the image. It takes a little practice, but it does work. There's a little tool that looks like a pair of scissors. And if you take the pair of scissor tool and you draw a selection around something, and then let go, it's drawn this green outline, then just hit the delete key on the keyboard, and it deletes everything that fell within that path I drew. So I got rid of part of the pad, but I have to keep zooming in here and changing my angle, to try to get rid of more of that pad If I cut too close to his head, I'm going to cut his ear off. So I keep repositioning this to get, a little bit more of it. And then delete. Yeah, it might help if I zoomed in. Get a little closer. These things are pressed right up against his head, so it's inevitable that you're going to either leave a little bit of the pad behind or you're going to slice into his head a little bit. But you try to get as close as you can without cutting too much of the head. Now, something to be careful of, I'm going to intentionally position it this way. I'm going to try to cut off a little bit more of that pad by looking at it from above. But I'll warn you right now, what's going to happen is I'm also going to slice off a big chunk of his shoulder, because the shoulder is actually falling within this outline. So it's creating a three-dimensional selection that extends, the full depth to the other side of the image. So when I delete that, okay, I got rid of some of the pad, but I just completely sliced off his shoulder and, cut into his thorax. But, so sometimes you have to just reposition it, like this to try to get more of that off without inadvertently slicing off his shoulder or some other, some other body part. Sometimes you get lucky and there's actually a little space in there. I mean, this one is right up against his head also. But you can kind of get rid of objects using that little scissor tool. Whoops, too far. I'm going to show you one other little tool quick, and then I think I'll be done, and you can just, use the rest of the class time to do your renders. Right next to the scissor tool is a little tool that's skull and crossbones. I would pay close attention to the icon and use it as a word of warning. Don't ever use it, because it does not work well. This is supposed to remove bones. So theoretically, I should be able to grab that skull and crossbone tool and click on his skull, and it will remove the skull and leave everything else. Actually, that worked better than it usually does. So made a liar out of me. That's actually kind of cool. But don't be surprised if you click on something like that with the remove bone tool and it just looks like shit. So, this one just happened to be kind of interesting. So I've removed the bone, and now I can play around with window levels. I can see his, superficial musculature. I can kind of peer into the brain a little bit. I mean, you can't really see much of the brain, but, see some of the vasculature in the head and the eyes. I could crop in more or less an axial plane. See what that looks like. You can see some of the circle of Willis arteries there inside the brain, inside the head. So go explore Horos. So since this actually worked better than I was expecting, I'm just going to play with this for a little while and see what kind of fun things I can do with it. But let me know if you run into any issues with this. Yeah. Did you click on on 2D view? Take here, and then either go into the 3D viewer menu or the 2D 3D button. My this data set. So for some reason, that data set literally has just those four images. So it's not enough images to actually reconstruct the point. So try, a different data set, maybe one of them is a portion share, because I know those are all fully 3D. Images. Are you in the like the one with the visible view data set this one here? Yeah, so when you come in here, like don't click down below next and now you what let's see just image. Yeah, just click on this thing here. And then when the download menu comes up here, you just image. Not.
Okay, now I know why it wasn't.
Okay.
Thank you.
Got Yeah, you'll download it as a zip. Then wherever it downloads it, like in your downloads folder, just double click on the zip and it'll expand it into a folder. So, yeah, the little doesn't work before. You have to do a little grab.
And there's just not. There's is. Whereas.
But there are you don't always. Oh, so. I'm English people, I got it. If you want to change the conversation. And then. Sorry, I realized I forgot one important little detail. When you want to actually save your JPEGs that you're gonna upload to my courses, for your assignment today, you just go to the file menu, choose export, and export to JPEG. But if you do that, you'll probably notice that you get all this extra black space in the image. If you want to get rid of all the extra black space, you can just grab the bottom right corner of the window and just resize the window. And so that'll give you a better composition. And so then you just export to JPEG and name it something that you'll remember. And so this would be like my volume model or something. Save it to my desktop and then just upload that to my courses. Yeah. Yep, and put the surface render in the surface model folder. All kinds of
It's just
interesting. Yeah, okay, so I know from the title that there's another. I don't know. Version of Horos in this computer. I just want to. I just want to do it. It's not something screwed up. So you can put it out. Looks like it's working. I just don't know why you ran into trouble with it.
I submitted the two J.
Okay. Yep. Yep.
There's a quiz on Monday, right?
Yep.
Have a good weekend.
True.
For the surface model, is there like a software like these?
No,
Oh.
yeah,
so
crop
the-
tool is only available for modern models. It's not available for the surface model.
Oh, okay, thank you.
It shows up in the service. Yeah, I think. When's this exercise?
Okay.
I think you may have, like, I've got someone sitting here. I got like a Zoom thing and a on-campus meeting, but it's gonna be kind of weird. I'm trying to think if there's someplace to leave it for you. Sure, yeah, I'll do that. Right, okay. Yeah, I'll run it up before they close. I don't know if they have closed or not. Up to the office. You know what I could do too is, would you mind if the art office is closed, could I just stick in your mail slot? Or do you think it would disappear from there? Yeah, not between now and tomorrow. Okay. All right, look for it in the art office, and like I say, if I couldn't get to them before they close, just look in the mail slot. Okay. Sure.